The objective of this project is to build somewhat of a duplicate of the RCA KU2A microphone that has two different ribbon sections contained within the head of the microphone. This microphone is by far one of the most beautiful microphones I've ever seen, I think, in my opinion. And I'll try to make a housing that is similar to this as well, but that'll be a separate project from building the motor that I'm discussing today. So the first thing I want to do is talk about the design. So I've got two different brass housings that hold within them the magnets on either side of the ribbon that is corrugated, and then the signal is generated when the ribbon moves within the magnetic field and it's transmitted down through the brass fitting that is on the other outside of the microphone itself. So in this section here, I'm basically cutting out the plexiglass that I'll use to hold both the ribbon and the magnets in place and keep them separate from the housing because I can't have them in contact with the housing itself. Otherwise my signal won't work quite right. So now here's the brass fitting, there's the plexiglass, and there's the magnet, and there's the design in which it fits into. Now I need to go ahead and etch out where the magnets are going to lie so that I can cut out the plexiglass. So I etch the plexiglass and then I take it over to the saw and I cut out those sections so I can put the magnets and have the magnets held in place around the ribbon itself. Now it takes a lot more sanding and a lot more filing that I didn't put into the video, but then I have it glued in place here, and you can see the magnets are held there, and then I glue the magnets in place. And then I need to file out a ridge for the ribbon to lie within, and then connecting the two different sections together and holding it in place with some non-conductive plexiglass so that it doesn't transmit the signal. But I need to make a bridge that connects the two different ribbons to each other so that the signal can be transmitted up from one ribbon to the second ribbon. And so I need to make a bridge that's isolated from the brass housing. And so I make a brass bridge here, and then what I'll do is I'll put some glue on the back side of it so that it doesn't come in contact with the brass housing, and the signal can move from one ribbon up to the other ribbon and down excuse me, through the brass housing back to the amplifier. And here's the magnets in place and the brass bridges in place. And now in order to hold the ribbon in place, I need to make some screws that I end up tapping into the housing, and then a wood section that has a little rubber on the bottom that will hold the ribbon in place. Now I decided to go with a cheap ribbon for this microphone. I did purchase a more expensive ribbon material, but I used basically silver leaf that you get at a craft store, which is a lot thicker than most of the ribbon that you see in ribbon mics. Somewhere around the range of 5 microns for the ribbons in the good microphones. So this is a lot thicker, but it was just for the intention of seeing if everything worked, and this is what you're listening to right now is the thicker microphone ribbon. So next thing I do is I put a signal through the ribbon at about 40 hertz, and you can see that it resonates the ribbon at about 40 hertz. It's a corrugated ribbon, and I have a separate video showing how I do the corrugations, how I made an apparatus to do the corrugations. And then I go ahead and put some additional magnets on the outside of the original magnets to increase the magnitude of the magnetic field on either side of the ribbons. And then there is a aluminum mesh in front of the ribbons that's held in place with some spherical rare earth magnets that are holding things in place really well. So it was a nice way to not have to glue things in place and take things off. And so it actually works pretty well to have the magnets hold everything in place. Now there was a bit of a hum when I was in close proximity to other electronics, so I made a Faraday cage to go around this, and I'll have to modify this a bit when I put it into the housing. But a Faraday cage, it keeps it separate. Now I'll go ahead and do a comparison between this microphone and a dynamic microphone that you'll see in just one moment. This is the dynamic microphone from approximately the same distance away.